All right. So last time we did sine and cosine, the periods were 2 pi over omega. These are pi over omega. There's only a subtle difference for tangent and cotangent. Secant is a reciprocal of cosine and sine, so they are very similar or the same as sine and cosine. Okay, so if you did cotangent, it'll be one of these. Okay. The homework is very short because I don't really want to focus on graphing too much. I want you to know what they look like, and I want you to be able to find periods or phase shifts. If I ask you on the exam, that's all I want. Okay. Well, let's do the first homework problem. Example 1. The graph of y equal to tangent x is stretched by a factor of 8 shifted a distance of 11 units to the left. Reflected across the x-axis then translated eleven units down. This will test all our ideas from college algebra and paired with the new stuff. Okay. Remember the whole shifting to the left, up and down, all that stuff is the same. Nothing has changed. Only difference is we're looking at a trig function instead of a polynomial. Okay, instead of a parabola, we got tangent. Okay. So the first thing we got to think about, look at the general form. We know that the A is the stretch, right? They told us they're stretching it by how much? 8. So I know for sure there's an 8 in front of my tangent. Now the stuff inside we got to figure out depending on what's going on. The inside of the parentheses is the horizontal part, right? Remember? When you had the original parabola, if it was x plus 2, it was shifting to the left 2, right? And if you put a minus in front, it would flip it downward. So this would be left 2, so it'd be over here doing this, right? So same ideas. They said they reflected across the x, that means I need a minus in front, not just regular 8. So the 8 doesn't stretch. Reflection needs to be minus. So we should put a minus right here. Okay, so far we got the stretch and the reflection. A distance of 11 units to the left. Okay. So what should be inside, right? Should we do minus 11 or plus 11? Inside the tangent.
Yes.
Yeah, plus, right? Okay. And then it says that they translate 11 units down. But we said how we do it last time. The K tells you if it's going up or down, depending on the sign. So it would be, what would be outside? Yeah, minus 11 because it shifts it down 11. Okay. So they tell you it's a tangent function. We did this to it, stretched it by 8, shifted it to the left by 11, reflected it, and then shifted it down. So we covered all those things. Okay, is that clear? Good. All right. Given y equal to -24, tangent of 5x plus 7. Well, actually, you know what? Let me use it different. Sorry. Let's use -17, tangent of 9x plus 8. What is your period? Or the tangent? Right? We said period is pi over the absolute value of omega. So it's gonna have a pi on it for sure. Divide by whatever is on the x. So what is it? Yeah, it's gonna be pi over 9. This will always be positive. Okay. You should not have a negative period. It's gonna be shifted. Okay. Phase shift. You just use that formula up top. What is it gonna be? Pretty much, but notice is one thing. They're very close. This was a negative, right? And then over here it's positive. So if we are positive, what do you expect it to be? Yeah, it has to be the opposite because there's no absolute values. So it's going to be, you said 8 over 9, right? But minus. Okay. So it depends on this sign. If it's plus, we'll then switch it. If it's minus, and put positive. Remember, if it's +2, you go to the negative side, right? It's opposite. Same thinking. Does that make sense? That's all I'm going to ask about graphing really is for all 6 trig functions. Can you give me amplitude, phase shift, period? Okay. I'm not going to ask you to graph by hand, but you should know what they look like. We're at the end of chapter 6 almost, so exam should be soon. Let's see. Let's pick a date. Today is the 25th. How about next Friday? Next Friday sounds good, right? It's over a week to prepare. So we'll finish, yes. We're gonna review together. So next week I'll just review on Monday, Wednesday, Friday, take your test. Okay.
Are we allowed to use like a formula sheet?
Yes. Just put all the formulas we talked about. No examples, just formulas. You'll staple it to your test. Okay. You'll turn everything at the end. All right. You can have a unit circle separately. It doesn't count towards your formula page. Okay.
I have a question. Do we need extensions?
No, you don't. All you need is a pencil And if you choose to bring a unit circle or formula page, that's up to you. That's all you need. All right. Nothing else. But most you should have 2 pages. Of course, you can put stuff on the back if you want to. Okay, I don't think we have that many formulas yet. It's just test 1. I think 1 page should be, I think honestly, a index card would be enough, but I don't mind you using a page or 2. All right, front and back. So 6.3 is the last section of chapter 6. Let's say we finish 6.3. And then we'll review Monday and Wednesday. 6.3 has a lot of formulas and ideas. Important ideas. Example 1. 1 second. That should be more information. Yeah, let me give you some definitions first, because they're pretty important for this section. Okay. Inverse sign. Y equal to sine inverse has a low -1. I know it's a little confusing to some people. That symbol means inverse, not reciprocal. Okay. It's only true for trig. So negative x means, by definition, that x is equal to sine y. Okay.
What's on the top and side?
A little -1. So that's a symbol for inverse that we're going to use. Some books use arc sign, which is more clear, but arc is more space in the book, so I think they use this to save space. That's my theory. I don't know why. I think arc is better. But anyway, so we need to know the sometimes called arc sign. So y equal to sine inverse x has a domain of -1 to 1. So knowing the domain range or having it on your note card or note page or whatever, that's going to be very helpful. And range of -pi/2 to pi/2. Maybe I should put, don't put it down here because it's too small. Okay. Number 2. The inverse consistency. Inverse cosine. So y equal to cosine inverse of x means x is equal to cosine of y. Sometimes called arc cosine. So y equal to cosine inverse of x has a domain of -1 to 1 and has a range of 0 to pi. Number 3, tangent. Do you guys remember how inverse functions work from college algebra? Maybe. So y equal to tan inverse means x is equal to tangent y. Sometimes called arc tangent. I don't know if you want to use arc, that's fine. I don't care what you use. Either one is fine. Y equal to tan inverse x has a domain of -infinity to infinity. Has a range of -pi/2 to pi/2, but with parentheses. No brackets on that one. So if you remember any of your college algebra, the reason they are restricted like this, because you know how the originals just keep going forever, right? Sine, cosine, tangent. They have to be restricted because by definition, you cannot have an inverse unless it is 1-to-1. Unless it's 1-to-1. And if it's repeating itself, it won't be 1-to-1. It would violate the definition. So a function can only have an inverse if it is 1-to-1. So they restrict it. Instead of having the function go on forever, right? Doing this nonsense, they kind of just cut it off. So you know what? It's not 1-to-1 if it does a horizontal line test. You guys remember that? And if they hit more than one, it's not 1-to-1. So they have to limit it this way. Okay, so they say, you know what? I'm just gonna look at the cosine that goes from where the sine goes from here and stop at that first peak. They cut it off. So now it's 1-to-1 if I'm gonna look at that section. All right. Once they do that, they define them this way. And the reason we care about inverse is because you can undo what the original function did, right? So if you plug in an angle, the sine, you get a value on the circle. So now the inverse would do the opposite. You would plug in a value and it would give you an angle. That's the whole point of this. In general terms. Okay. So when you're using these, make sure you're within these values. If you're not in there, then it's undefined. So they give you a question with like sine inverse of some weirdo number that's outside of here, then it's undefined, okay? Let's do an example. So the first thing they're gonna have you do, let me find it. Is apply the definition. But let's start off just something simple. So first thing actually, yeah. Find the exact value. Part A. So sine inverse of square root 3 over 2. So what this is asking in plain English, what is the angle whose sine is square root 3 over 2? I was looking at your circle. Which angle gives you a y value of square root 3 over 2? Yeah, it's going to be pi over 3 or 60 degrees, right? Same thing. So sine inverse of this value is going to give me an angle. That angle happens to be pi over 3. Now, if you apply the definition, just so we're comfortable, sine inverse of square root 3 over 2 equal to pi over 3. Remember we said it at the very top. Some number equal to sine inverse of a value, right? So this is the angle. Some angle equal to this means this. So change it. Apply the definition just for fun. I mean, they didn't ask for that. They just wanted this. But just so we know. Apply the definition. So this would become sine of pi over 3 equal to square root 3 over 2. Whenever you do an inverse, you can always go back to the regular step. Okay. That makes sense? Right. Anyway, they only wanted this part. Part B, cosine inverse of -1. Where is cosine -1? Which x value, or which angle gives you an x value of -1? Yeah, it's gonna be pi, right? So using our definition, or just our unit circle, it will be pi. Right, using the definition again, we know that cosine of pi is equal to -1, right? Only one is this, though. So far, it's straightforward, right? You just look at the circle, find it. Now, if it's not known values, it gives you something really weird. Now you're gonna have to use the calculator, scientific. There's no way around it. You should always check though, if it's too big. So we have to know the range of values for sine. We said sine is -pi/2 to pi/2 for the range. And domain we said was what was it again? -1 to 1. So if this value is outside of here, then you can't do anything. You just write undefined. That's it. If it's too big or too negative. Same thing with the cosine. All right, I'm gonna do another example. You guys cool on number 1? All right. I'm gonna turn the page. Is that fine? Okay. So let me know. I don't want to go too fast or for no reason. This time, try to find these on your own. What is sine inverse of 1/2? Cosine inverse of 1/2. What is cosine inverse of 2? So the first two are on your circle, right? The last two, maybe not. Yeah, the inverse for cosine has to be within -1 to 1. I think move it too big. That's outside. So undefined. What about 0.09? Is that's still in here, right? You should be fine with that one. Just plug it in your machine, see what it says. Undefined. Now, when you're doing this on your homework, make sure if they're asking for degrees, change your machine to degrees. If they're asking for radians or you see pies or something, change to radians. Don't forget. On the exam, I'll probably use degrees most of the time. I don't really care what you use, but the homework is going to be very specific. So if you have one of these, just hit mode. And you should have an option somewhere in there. If it's an older one, you got to scroll down and you'll find a degree or radian. If you need help with that, let me know. Unless you have something really fancy, then no idea. I'm gonna do radian, I guess. That's what we've been doing for no reason. Cosine inverse of 0.09. Whatever that is. Okay. Any questions so far? Is it okay? I think there's one more idea we need to cover. Can you open the homework real quick? Looks like most of the problems will be similar to what we just did. You need to know when to use or how to use a circle and when to determine if it's undefined. They'll ask you definition question as what is the domain, what is the range, which I gave you. The weird stuff is here. Once you get to 11, things change. Let me do one of those. We'll do two more examples, and if we have time, we'll do some homework. Find the exact value. Whenever you see that, an exam or homework, they want you to do it by hand, no calculators. Okay, show your work, give me an actual non-decimal answer. All right. So part A, sine of tangent inverse of 12/5. So technically your calculator can give you a decimal, but that's not what we're asking. The way I want you to think about this is say, you know what? Let theta equal to tan inverse of 12/5. That looks weird. Now apply the definition. This is when that definition becomes important. If theta is equal to tan inverse, what is the original form? Do you see it? Right? We said that if I plug in a number into an inverse tan, I get an angle. The original takes an angle and gives you that number. So by definition, whoops, tangent of theta is equal to 12/5. So the way I want you to think about it, this picture, this is some big angle inside, some theta. Okay. I know it looks weird, but it's just some theta. So let that theta be that. So essentially what they're asking is what is sine theta? So build your triangle based on this and find sine. That's what they're really asking. Just find your sine. So build the triangle. You're gonna have to build one every single time for these types. If tan theta is equal to 12/5, that means that opposite and adjacent are 12 and 5, correct? Go back to what we talked about last time. We need hypotenuse. Once you do your Pythagorean theorem, should be 13. I'm gonna skip the Pythagorean. Is that okay, or do you want to see where the 13 came from? What's up?
Where did
So what you would have to do is this, plug in the A and B. So 5 squared plus 12 squared, that's what, 169. So that means that C is equal to the square root. Technically plus or minus, but you never put a minus on your hypotenuse. It's always positive. Another way to think about it is this one of the magical triangles, 5, 12, 13, like 3, 4, 5. It's always going to be that way. If you have these as your legs, hypotenuse will be 13 every time. But you can always solve it if you forget. We have a right triangle, so we are allowed to use Pythagorean. Okay. So the question is really asking, what is sine theta? Just make it a little prettier. So sine of tangent inverse of 12/5 is equal to sine of theta by our definition right here, which would be opposite over hypotenuse. So this is the answer they want. But does the logic make sense? It's like, because it's a little weird. Not gonna lie. But you see that we're using that inner part to define the triangle. Once you have it, find the sine, whatever's out here is the question. So find the sine given this is another way to think about it. Is that fine? Does that make sense? You will have one of these on your test for sure. Okay. So they'll have a couple of these on the homework. The ones I like are the ones that don't have numbers. Any questions on example 2? Let's do another one without any numbers. You guys cool on this page? Right? Example 3. Complete the identity using the triangle method. Cosine of tangent inverse of x. So there's no numbers, but the approach will be the same. The first step, let theta equal to the inside, because the inside is technically some angle, right? Step 2, apply definition. Theta equal to tan inverse implies that there is an angle that is equal to x. That's the definition. Step 3. Step 3 will be build your triangle using tangent equal to x, tangent theta equal to x. place your theta in the correct spot, or whatever spot you want, but I like the lower left myself. Build your triangle using tan theta equal to x. This is the same steps as our last example. I'm just trying to be more clear. All right, so tangent theta is equal to x. You agree that this is the same as x over 1. Let me write that prettier. You can always put a 1 underneath. So I can use the opposite over adjacent. Opposite adjacent. But find your hypotenuse. C squared is going to equal a squared plus b squared. It doesn't matter what you choose for a and b. I just think of it as the legs of the triangle. You can put either one in either spot. Okay. C squared would equal 1 squared plus x squared. That means that c is equal to the square root of 1 squared plus x squared. Or if you prefer, x squared plus 1. You want the x first. Doesn't matter though. 1 squared is just 1, so you don't have to write it. So we have hypotenuse. So now that we have the triangle built, answer the question. Right? That's technically what they're asking. What is cosine? So cosine of tan inverse of x, which is equal to cosine theta because we defined it to be equal to theta, would be equal to what? What is cosine? Yeah. Be the adjacent side 1 over hypotenuse. So half the homework is just finding the angles on the circle or calculator. Yes.
Wouldn't getting the squared on the C also get rid of the squared on the instead of the one?
No, it won't cancel that square unless it was by itself. Like if it was like this, then yes. If it was like this by itself, yes. But not like that. It has to be like a factor, the whole thing. Okay. Like this is technically the entire thing, and so with this one, only that one is squared. So you can't. So be careful. It's a common question. Any other questions on example 3? This is what they wanted. All right. Let's see. You know what? How about you try one? So you remember. Are you guys cool on this page? Not yet. All right. Oh, wait a second. Friday, I might have to go to a funeral, so I'll let you know and remind if we won't have class. So just, I'll let you know tonight. If not early, latest tomorrow. So we'll review Monday, Wednesday exam next Friday. Okay. This is the last section on test 1. Sine of secant inverse of X. I'll start you off. Let theta equal to secant inverse of X. Solve this yourself. Build triangle. So if you put your theta here, secant theta is equal to X over 1, which is what? Where does the X go? Yeah, it's gonna be a here, right? So solve this side. So C squared is equal to A squared plus B squared. C squared is just an X. A is 1. I don't know what B is. Let's find it. Let's move it over. Move the 1 over. Square root both sides. And get to here. So this side is square root of X squared minus 1. So now answer the question. What is sine of secant, which is actually sine of theta? Yeah, so it's opposite over adjacent. So opposite side. Don't forget. It's right there. And here. All right, guys, we'll stop here. If you have any questions, let me know. No, I'll see you. Well, I'll let you know when I see you, I guess.